In this lecture, we'll perform circular convolution using matrix multiplication method. In previous videos, we have already studied how to perform circular convolution using time domain approach, frequency domain approach, and concentric circle approach. This is another way of calculating circular convolution, which is with the help of matrix multiplication. So here let x1 of n is n points sequence. So here assume that n varies from 0 to n minus 1. Similarly, we'll take another sequence x2 of n is also n point sequence. Okay, we'll assume here also n varies from 0 to n minus 1. Then the circular convolution between x1 of n and x2 of n, that is y of n, will be equal to x1 of n circular convolution with x2 of n. So in matrix multiplication method, the first column supposed to be y of n, that is y of 0, y of 1, y of 2 up to say y of n minus 1. This is the output matrix column. Now we are supposed to write the first sequence, that is x1 of n, in first column, that is as say x1 of 0, x1 of 1, x1 of 2, and the last sample is x1 of n minus 1. Now we are supposed to do circular shifting on x1 of n sequence, that is while writing the second column we are supposed to shift this value on the top, that is x1 of n minus 1 should be written here, then x1 of 0 sample should be written here, this sample will be written here. Likewise, here the last sample supposed to be x1 of n minus 2. Similarly, now this sample supposed to be written here, that is x1 of n minus 2. This value is shifted here. This value should be shifted here. Here the value will be x1 of n minus 3. Likewise, here at the end we will get the last sample as x1 of 1. Similarly, here we'll get x1 of 2. Here we'll get x1 of 3. Similarly, here we'll get x1 of 0. So this is the way of representation of the first sequence x1 of n in matrix form by repeatedly representing. This is the way of representation of x1 of n in matrix form. This is way of representation of x1 of n in matrix form, that is x1 of n is written in each column repeatedly by circularly shifting. The remaining x2 of n matrix supposed to be written here as a column matrix, that is x2 of 0, x2 of 1, x2 of 2, x2 of n minus 1. Now we'll take one example. x1 of n is 1, 2, 3, say minus 1, and x2 of n is 4, 3, 2, minus 2. Here we can see that n is equal to 4. This is the first value, that is x1 of 0. This is x2 of 0. So that here n varies from 0, 1, 2 and 3. I will try to find the circular convolution between x1 of n and x2 of n, that is, say y of n is equal to x1 of n, x2 of n. So according to this, the first matrix is the output matrix, that is y of y matrix, that is y of 0, y of 1, y of 2 and y of 3, that is y of n minus 1. N is 4, that's why it is 3. The next matrix is x1 of n matrix. First, in first column, x1 of n value should be represented, that is 1, 2, 3, minus 1. Next, as we seen here, x1 of n minus will be circularly shifted here, and then this will be shifted here, this sample will be shifted here likewise. So this minus 1 will appear here, this 1 should be moved here, this 2 should be represented here, and 3 will be shifted here. In next column, this 3 will be shifted here, this minus 1 will be shifted here, this 1 will be shifted here, this 2 should be shifted here. Now this 2 will shifted here circularly, that is 3, this is minus 1 and this will be 1. Here we can see that the last value is x1 of 1, that is here we can get x1 of 1 is 2, that is 2 is written here. So this I can show. So this 1 shifted here, this will be shifted here, this will be shifted here. So now the x2 of n matrix supposed to be written here as a column matrix, that is 4, 3, 2, minus 2. Now perform matrix multiplication, that is 1 into 4 is 4, minus 3, 3 into 2 is plus 6, 2 into minus 2 is minus 4. Similarly, second row, this column, that is 2 into 4 is 8, plus 3, minus 2, minus 6. Next 3 into 4 is 12, plus 6, plus 2, plus 2. Next minus 1 into 4 is minus 4, plus 9, plus 4, minus 2. So simplifying this, we'll get this is 3, this is 3, this is 22, and this is 7. So therefore y of n is equal to 3, 3, 22 and 7. This is the circular convolution between x1 of n and x2 of n. This is the most easiest method for calculating circular convolution between two sequences. Thank you for watching.